innate interest as a youth in science. My cousin, who's here today, Dr. Robert Anthony, and who graduated from this university, was far more the science student. Yet, he became a clinical cardiologist. I too went to medical school, but quickly went into lab research. Why? Maybe it derived from the subconscious memories of my sister's horrifying experience. The lesson, maybe, is that throughout my career, expect the unexpected. That's what probably was the main thing over and over again. However, when I first attempted to do research, when I was 19 years old, during my earliest years in college, and again later in my earliest years of medical school, my first attempts were disastrous. I failed several times over. Time forbids me from telling you all these stories, but I'm going to tell you one. When I was in college, I read a pamphlet that said, nobody in the world knows the function of our thymus gland, that is responsible for the development of our T cells, critical to our immune system, we now know. And so I thought I would simply operate and take out the thymus gland, so I sent about 300 mice home to my mother in Connecticut, in Waterbury, and told her to take care of those mice until I came home. Well, I came home in the summer, the mice were there, and I performed my surgery to remove the thymus gland to see what happened. I did this many times. All the animals died, so I knew the thymus gland had to be important. They all died. But then I looked a little closer and I saw that I had cut the arch of the aorta or the heart. So I have to tell you that there were lessons from this. Number one, I would never be a surgeon. Number two, and more telling for everyone and for you. You have to know the tools of your trade. You have to walk before you try to fly. So that is a slow lesson for me because I made the same mistake a few more times before I realized the lesson in this. But again, there's still another lesson, and a large one, and you've all heard it since you were children. If you try to do something, you may fail and fail miserably, maybe many times over, but don't let fear of failure stop you. Anyone productive who really would imagine in any field, not just science, but any field, has failed many times. Against all odds, I made it to the National Cancer Institute of the National Institutes of Health in Bethesda, Maryland. This was during the Vietnam War. Very competitive to get in there. I thought I would leave after 2 years of what was called military service. Not exactly military. But I ended up at the National Cancer Institute for 30 years. Again, expect the unexpected. I was supposed to work in an immunology research lab, but my mentor, or my immediate boss, left to go to a university. It was Duke. I was pushed to work on leukemia. This was maybe already on my mind. I was, excuse me, rather alone. I didn't have a mentor for quite a while. After this period, I worked for a few decades in this particular area of cancer research and blood cell biology. For a number of reasons, it led me to the study of viruses. I originally had no interest in viruses. A few decades later, the AIDS pandemic appeared, which would be due to another virus, HIV, of course. From my experiences with virus research, as well as working with blood cells, I believed I could be useful in this area, so I began working on the problem. Quickly, AIDS research moved across the laboratory boundary to the public health and clinical arenas, but as well, political, social, economic, education, and legal issues. You can imagine these were areas I never dreamed I would be involved in, but really was, heavily so. How about a word now about AIDS? There are about 35 million infected at this moment, estimated. About 30 million that are already dead from HIV infection. 20% of all patients worldwide now in therapy. A huge improvement from the few percentage of 5 to 10 years ago, but nowhere near enough. What does having treatment mean? It means converting a tragic, horrible, much suffering, and soon death problem to almost a normal lifespan. Not perfect, but infinitely better. What's the challenge? The challenge is to make it into a cure. The challenge is to bring the therapy to all the developing nations of the world. Those are the challenges that you, in any field that you're graduating from today, master's or PhD, no matter the subject matter, can contribute heavily to if you choose to. This is far beyond just a scientific problem. Those are some of the needs for the now and future. It is true that the President's emergency plan for AIDS relief has done enormous service. It is the main thing responsible, the United States government, for much of the treatment today in Africa, for example, and some of the Caribbean nations. Our institute is a recipient of an extraordinary amount of money from the United States government, from the President's office to help. We are in 7 African countries, 2 Caribbean countries. We're involved in the care of approximately 600,000 patients. But what about America? You don't hear about HIV and AIDS anymore, at least not very much. How many are fully aware that we have major problems in some of our cities, and in particular in the East Coast? You know that Baltimore and Washington, D.C. have areas of infection that are greater, or at least as much as any part of Africa. Yes, it's true. Sometimes a marginalized group, relatively poor African-American people, as at the beginning it was a marginalized group of gay men that were particularly known for having the disease. This is now a heterosexual disease, but it's impacting some of the so-called urban centers. I wrote twice in the Washington Post calling for the PEPFAR to be applied also to our inner cities, to make it so that we are brothers and not just padrones to the people, for example, in Africa, and also to recognize this problem. It is severe. We care for every day, on and off, depending on what particular group, but it's about 6,000 patients in Baltimore that our institute is involved in the care of. How do we make prevention? Surely education plays a role. Education is absolutely essential, but it's absolutely not sufficient. We now know that circumcision is a major factor. We can greatly reduce the amount of infection by male circumcision. We need to get it out there more with education and finances, I guess. But there's also an approach by using drugs against HIV. Drugs that we use to treat people can be used to treat very high at-risk populations, and that greatly lowers the amount of infection. Is this a new principle? No, we know it a long time. Laboratory worker exposed can take certain drugs, you don't get infected. But it's now being applied. Does it have any risk? It's going to be costly. Does it have any other risk? I worry that we might create some HIV additional resistant variants. But it is going on. Find people at risk, treat them ahead of time before they become infected, you prevent infection. The ultimate is a vaccine. And back to the Gates Foundation, and I'll tell you just a couple of sentences. Our Institute's candidate vaccine, I think, will be the first brought forward from soup to nuts from the Gates Foundation and go into clinical trials next year as a preventive vaccine. Are all the answers with vaccine available? Will ours work? We have reasons to believe it'll be the most interesting and exciting candidate brought forward. But we have scientific as well as social and other kind of problems to solve to make this a very good vaccine. One lesson, sorry, get ahead of myself. There are positive spin-offs from the horrible tragedy of AIDS. Can you imagine? There are, not just to science, but also to society. For example, there's much greater understanding, interest in women's rights in various countries, stimulated by the AIDS epidemic. There's much greater interest in patient activism for different diseases that came out of AIDS activism. There's much greater tolerance for differences in understanding of differences in sexuality. And there's a far greater involvement of North and South. For example, the role of the United States in helping Africa and some of the Caribbean nations, far greater than before. Another lesson that came out of the AIDS work for me was the difficulty of bringing research from the laboratory to the clinic. So that's when I decided to form a new virus center called the Institute of Human Virology in Baltimore, which includes basic science, epidemiology, and public health, vaccine research and clinical under one roof, with outlets, of course. A final lesson was learning that we must have responsible virologists for new viral and possible epidemics. You can say, of course we do. We have the WHO, they don't do science, they're administrative. We have the CDC, they do a great job. The CDC is responsible for chemical, for bacteria, for fungi, for accidents even, for radiation problems. So they're expert in some viruses, but there's this many viruses. They have expertise in that many. Along with a decline in training of young medical virologists, for reasons I won't go into today here, I will tell you that was a cause for concern. Those of us who got involved in AIDS as scientists, who helped solve this problem, got involved out of chance, out of a whim. That has to change. We recently established the Global Virus Network, or GVN, a network internationally of experts in virology for the purposes of being available for consultation. And I can give a dozen reasons off the top of my head of things that could have been done much better if this kind of network had previously existed. Getting the best of the best to communicate, collaborate, be available to consult, be available to train the next generation of virologists. I am happy to say we have great help from a Connecticut lawyer, also from Waterbury, and boyhood friend who's also here today, Mr. Tim Moynihan. But as I near the end of these comments, what is a life and what are the opportunities in the biomedical sciences? A career in biomedical science involves hard work, can be long hours, and as I've already noted, failures are not rare. But the rewards are immense. They include the thrill of discovery, finding something new for the first time, the thrill of developing a new idea that pans out to be right, having friends all over the world, and students, some of whom will excel and bring you a special kind of pride as you yourself mature and are less competitive for yourself. There will be many good opportunities for work, whether in university, independent institutes, health centers, companies, pharmaceutical or biotech or otherwise, state government, federal government, hospitals, and many more. Perhaps my selection of topics, so limited to the biomedical sciences, has been unfair to the graduates not involved in science or engineering. But that's it because it is what I know. It is what I do. But to those other graduates, I assure you that those of us in the generations above you are keenly aware there is no science without an economically, reasonably prosperous world. Science also does not flourish with unfairness, severely limited when parts of the world are omitted because of poverty, injustice, and corruption. It is equally true that the heaviness of life would be far less bearable without the beauty and the stirring of the imagination provided by the arts and humanities. So we expect you to be among our future leaders, providing the best education to the newer generations, preserving our best traditions, and guiding us to make a more beautiful, just, equal, and prosperous world. I close by saying we, or at least I, can only be envious of you, the new graduates. You have youth and opportunity. You have been educated in a prominent institution. If you stay or come back to the University of Connecticut, you will be arriving at a time, a particularly exciting time, of historical growth and development now being planned, in which I have little doubt will make this university a world leader. What a great opportunity this will be, and what a nice challenge for you. Again, my congratulations, and my sincere wishes to all of you that your wishes all come true.